Today's webinar is being recorded, and we'll make sure the recording is available to you within the next couple of weeks. If you have any questions during the presentation, please submit them using the Q&A box in Zoho Webinar, and we'll address them at the end. Charlie will be presenting for about 30 minutes, and we'll reserve the last 10 minutes for your questions. Please take a moment to review the disclaimer on your screen. The webinar is intended for informational purposes only and doesn't constitute professional advice. The views expressed are those of the presenter, and the session is being recorded, and by participating, you consent to that recording. So today's webinar is the first in a three-part series on functional safety for the process industries. After today's session, I encourage you to register for our two upcoming webinars. On April 21st, we'll be presenting Beyond PSM Audits, Functional Safety Assessments that Expose Hidden SIS Risk. And on May 12th, we'll wrap up the series with From PSM to Performance, Your Functional Safety Deep Dives. We'll have registration links and QR codes on the screen at the end of today's session, so that should make it easy for you to register. For those of you who may be joining an Accutech webinar for the first time, just a few brief words about us. Since 1994, Accutech's been a global leader in consulting, training, and software solutions for the process risk management. We bring deep expertise in both the management and technical aspects of risk, and we work with organizations ranging from the world's largest companies to government agencies, all with the goal of improving safety, security, and operational performance. So, what are we covering today? Process safety managers routinely take credit for PHAs, for safeguards during PHAs, things like high-level shutdowns, relief valves, and safety instrumented systems. But how do you actually verify that those safeguards deliver the risk reduction you're claiming? And that's exactly what today's session is about, giving process safety professionals the functional safety knowledge they need to properly evaluate and justify risk reduction credit for PHA safeguards. So it is my pleasure to introduce today's presenter, Charlie. Charlie is Accutech's functional safety lead and brings over 25 years of engineering and consulting experience in instrumentation, controls and automation, functional safety, and industrial cybersecurity. He holds a number of impressive credentials. He's a licensed professional engineer, a project management professional, and a certified automation professional. He holds both IEC 61511 safety, functional safety specialist, and IEC 62443 cybersecurity specialist certifications through ISA. Charlie leads Accutech's SIL verification work and is deeply involved in the ISA community, including as a founding member of the ISA Global Security Alliance and a member of the FBI's InfraGard program. And he's exactly the right person to be guiding us through today's topic. So Charlie, the floor is yours.
All right. Well, thank you all for joining today. I'm Charlie Souza, and I've spent the last 25 years or so working in the process industry. Half of that time as instrumentation and electrical controls engineer, doing most of your controls and automation work with DCSs and PLCs and instrumentation in general. And the last half of my professional life in functional safety, and much later in adding cybersecurity, a cybersecurity element to that functional safety. A quick poll, just so we can gauge the audience and cater to the audience in terms of content. I would like to know who is on the PSM side, the process safety management side, and who here is from the functional safety side, right? So who is the technical functional safety engineer type person, and who is here from a PSM perspective, just wanting to know more about functional safety? Stephanie, can you help us with that?
All right, so I believe you could see the poll. We've got 44% process safety manager, 18% functional safety professional, 15% for both, and then other is 22% of our audience.
Okay, good deal. So I don't see it in my screen here, but if I remember the numbers correctly, PSM is our majority.
Correct. Yes, 43% and an additional 14% that are both PSM and functional safety.
All right, perfect. That's the type of audience we were striving for. So over time, like I said, the last half of my professional career have been in functional safety, process safety, and working under PSM or with PSM personnel. I've noticed a persistent gap. Most plants have strong PSM programs, which means that they do PHAs, they do LOPAs, they even maintain safety instrumented systems. But these activities often operate in silos. You have your PSM group, your PSM team, responsible for staying consistent with their PSM program requirements, OSHA requirements. And in parallel, you have your functional safety team, who in most cases will have a functional safety management program as well, similar to a PSM. It's a FSM. In most cases, we do have an FSM. A lot of times, depending on the maturity of the company, we may not have a full formal program for functional safety. Nevertheless, these two tend to operate in silos. And a lot of time, one assumes the other one is taking care of a particular item, and we get the infamous falling through the crack type of situation here and there with a particular item, right? So that's why we're here today, is to educate not only PSM managers, but those who are coming with a functional safety background, to give them a little bit of what the PSM is or how we interface them both. So in today's agenda, we are going to talk about, as I said, a little bit repetitive here since I've already covered, but we're going to talk about identifying exactly where the integration break usually happens. You've got a PHA, a heads-up that identifies instrumented safeguard. That safeguard could be an interlock, and this interlock will be mentioned in a LOPA as reducing your risk. Usually that interlock is enough to reduce your risk to within tolerable level. But then the question surfaces: can you prove that this interlock was actually designed and tested to deliver the risk reduction you claimed? And the idea is PSM will do the heads-up, and the LOPA will should have a functional safety person within that PHA, which is an umbrella covering heads-up and LOPA. But what happens after that? Right? Is PSM just handing that over to the design team and washing their hands, or is functional safety picking it up on the other end and working in partnership or working in tandem with PSM to report back and guaranteeing that that reduction factor has indeed been achieved, right? We're going to look into the safety lifecycle itself. For those of you who are not familiar with 61511, we're going to go through that safety lifecycle in broader, right? We're not digging deep. This is not a functional safety technical course. We're going to look into the 61511 as a RAGAGEP standard, and therefore something need to comply to according to OSHA standards, and how we can connect PSM items such as MOC, MI, and SIS requirements from the functional safety management aspect of view together. And we're going to finish the presentation with a practical implementation and audit readiness. I'm going to be showing some questions, tricky questions, or typical questions that I've come across, and either clients ask me or I ask my clients during audits to check whether or not the clients are ready or prepared for an audit, or in good shape. So the challenge we're addressing, you have PSM programs. Are they truly integrated? If you think of how I said, we have two programs basically running in tandem with the process safety management and the functional safety management, and they need to be truly integrated. OSHA expects RAGAGEP. There are tens of RAGAGEPs out there, API standards, ASME standards, instrumentation standards, as well as functional safety standards. And when it comes to functional safety standards, IEC 61511 is the most widely used, not only in the US, but overseas as well. We have different flavors of it. Here in the US, you may call it ANSI ISA 61511. It used to be called ISA 84 back a couple of decades ago. And but there are others internationally speaking, but IEC 61511 being the most widely adopted, accepted all over, especially here in the US with OSHA. So how does that fit in PSM? Risk reduction must be verified and validated. Like I said, after the HAZOP and LOPA has dictated how much risk reduction it is required, someone must verify and validate that during design, testing, and operation. And that would be, let's think of it as a safety function, right? That would fall under the functional safety management lifecycle. And that person needs to report back and needs to make sure that throughout the project and beyond project, but in operations, all of that is, all of the 61511 requirements are achieved. So the risk reduction is true, is real. MOCs often misses instrumented safeguards. And again, these are challenges we're addressing here, we're discussing. MOCs often misses instrumented safeguards, creating gaps. Not only MOC, but items such PSI, process safety information, depending on the age of the plant. You may have brand new plants in which your EPC will hand over this pristine, beautiful package, but you may have older plants in which it's harder to find PSI information, using that as an example here. And usually your auditors will ask, and here you can think of an internal auditor, an external auditor, like Ecutech. We do audits all over the world, or it could be an OSHA auditor asking you. But the typical question is, can you prove your SIS delivers the claimed risk reduction? So RAGAGEP and PSM, as we know, as I said, IEC 61511 is the RAGAGEP for functional safety. RAGAGEP, for those of you who are not familiar, it stands for Recognized and Generally Accepted Good Engineering Practice. Again, 61511 is the one we're talking about. And OSHA's expectation is that your SIS design, your safety instrumented system design, is designed, your system is designed, implemented, verified, and validated following that standard, following the requirements of 61511. The audit reality is that inspectors review for functional safety lifecycle documentation. Now, I want to present a caveat here, is that there are two types of audits here, and we are going to focus on a PSM audit, or our examples are going to be PSM audit examples. We have dedicated functional safety audits that are less common, nevertheless required by 61511. If the company has a safety management system, that company is required to conduct audits every once in a while. 61511 is a performance standard, so it will tell you you must do it. But from a PSM audit point of view, what I see is that the questions tend to leave SIS out of the picture. The questions go straight to, do you have documentation? Do you have MOCs? Are you doing this? Are you doing that? And the functional safety, particularly functional safety, in the case of this presentation, is left aside, assuming that, or we all assume that you have a functional safety management team or person who is doing the same on your functional safety equipment or systems, right? So the goal here is to, or the strategy we use is to comply not only with the OSHA PSM, but also with the 61511 functional safety management requirements as well. So in other words, to demonstrate the life cycle adherence and design verification while we are conducting your PSM audit. And that will become more clear as we move on over to the slides, to the rest of the presentation. A quick reference, we're not digging deep into this, we're not covering each one of them, but as a reference, we have the 14 PSM elements. For the functional safety only folks here in the audience, you'll be able to go back on the recording later on, and you can review those in more details. But you can see, I will say ahead of time that functional safety engineers will recognize some of these as also present in the functional safety management or the functional safety life cycle. In other words, they're required on 61511. And as you can see, they are required by OSHA PSM as well. In other words, you need to have not only a PHA or not only mechanical integrity of your basic instrumentation, but you need to keep 61511 in mind and keep documentation, keep records of everything that involves your safety integrated systems, instead of leaving them split, right? Assuming that the other team, the functional safety team, is doing that audit, is doing that validation. Again, as reference, this is because we have international audience. We have folks from Europe, we have folks from Asia attending today. Just to give you guys a source of reference to go back and review later on if you need to. But here we're looking at Europe and US, and I dare to say international covered elements. Now, focusing on the safety life cycle, now that we looked at a little bit of PSM and in general, an overview of what elements we're talking about and how similar most of them are to what 61511 requires as well. We're going to look at the safety life cycle, the big picture of 61511, and tie that back to PSM. So number one would be the hazard and risk analysis. We have that on the 61511. It's asking you to conduct that, as well as we have that on the PSM. So they go along. After that, we have the safety requirement specifications. We have a series of documentation and paperwork that is that you start to build the requirements, design requirements, and operation maintenance requirements for that safety function to carry out, to give you the risk reduction that the step one that your HAZOP LOPA has is requiring from that safety function. We have the third item here, the sys design, where hardware and software are verified to meet requirements. So here you go through your detailed design. You are towards the end of detailed design. You may be conducting your FAT. You may be conducting some verification, seal verification. In other words, you want to make sure that what is designed is has reached the risk reduction factor that your HAZOP LOPA has required. So both on number 2 and number 3, you're building up to design something that will be equivalent to what you're asking for at the LOPA. And finally, we go through installation and commissioning. So far, you've tested that at design, at FAT, or even at SAT, site acceptance test. Everything looks good. You're still meeting SIL 1, you're still meeting SIL 2, whatever risk reduction factor that comes out to be on your LOPA. But on your installation and your commissioning, there are things that you must do and record in installation and commissioning that will also contribute to keep that risk reduction factor. In other words, if you don't do those, there is a high chance that the risk reduction factor is going to decrease. You're not going to achieve it. And again, the message I want everyone to get out of this presentation is that what you decided in LOPA, do you have that in the field? What you installed in the field is what you've requested in LOPA, right? Are your credits achievable, have been achieved? Are they real? And last will be the operational phase, operational verification with periodic proof testing and maintenance activities. Just to give us an idea of where we are, for those who are not technically involved in safety instrumented systems. So if we look at our classic process safety onion diagram, we'll see that we are right above process basic process control system and alarms and operator intervention. So we are a layer right above your PLC or DCS system. So, and I'm gonna say this again, in my opinion, the fallacy is that the PSM team or the PSM audit tends to focus on that basic process control system, tends to focus on alarms and operator intervention, and leaves the safe system-enabled systems for the functional safety team to take care of or to be responsible for achieving or going by their own requirements, right? Just like I did with the PSM, with the 14 elements of PSM, I want to show you just a quick overview of functional safety lifecycle. You know, at first you have quite a lot of information here. I don't need we don't need to follow each box in order here, but some things I want to point out. The reason why I have this on the slide is that you can start relating, you can start combining even or comparing any items directly to the 14 elements. We're supposed to have audits within the functional safety lifecycle. We're supposed to obviously have the HAZOP and LOPA. It's the same HAZOP and LOPA we're talking about under PSM. We're supposed to have a proof testing, which will come into mechanical or would fall under mechanical integrity or be in the realm of mechanical integrity. We have MOC. We have we have a safety lifecycle management, which I referred to as FSM in the beginning of this presentation, functional safety management as well. So just like OSHA requires us to have a PSM 61511, which is a RAGAGEP, one of OSHA's RAGAGEPs, and you're required to follow, requires you to have an FSM, functional safety management. Again, that could be someone or a person or a team within your functional safety group, department, or team, or that could be, I have seen many times, the PSM personnel, they are trained or they know enough, they're qualified to exert both, to do both, to look not only over the PSM, but look over the functional safety management or FSM as well. And that's really neat, because that person or that team is making sure it has enough knowledge to make sure that we're not dropping the ball on neither one, right? And if we get audited on the PSM, you're going to have your FSM, your functional safety management documentation, ready to be provided to that auditor. If the auditor decides to go a step further and start asking you safety submitted system related questions, right? And you may say, well, we've been audited before, internally, externally, and even by OSHA. Nobody has asked us any questions about 61511. Nobody has asked us any questions about functional safety management, or we have never had to show any documentation. Well, I just my screen blanked here. So even though you may not have been asked that 10 years ago, as far as 10 years back, I remember being involved in 61511 certification training as an ISA instructor, and we had OSHA auditors in the audience. So we're talking about mid 2010s. I saw and met OSHA auditors taking 61511 classes to become familiar with it and apply that or add questions or refer to 61511 in their audits or investigations, right? So step one, we are very, very familiar with it, the hazard identification part of it, the PHA HAZOP. The concern, of course, like I said, is integration, is not only to have a functional safety person attending your HAZOP and LOPA, but also traceability of that, records of the risk reduction factor that you are required to have that permeating throughout your functional safety life cycle as well. So you need to not just get to LOPA and say we need RF of 100 or we need SEAL 1 on this interlock, but accompany and make sure that your functional safety team or your design team is keeping that all the way into installation and operations. You still have SEAL 1. You're still achieving SEAL 1, right? You're taking credits in your LOPA for something that is real and it is installed in the field exactly how you meant it to be. Step one, the risk quantification, which is the LOPA. Once again, critical LOPA links PHA findings directly to the SEAL assignment. So this is the door in which we go from not involving functional safety. So far, we have basic process control interlocks, and now in LOPA, all of a sudden, we have the need for safety functions. And now we're involving functional safety folks. Now we're involving the functional safety team. And again, if the LOPA says you must have a certain risk reduction factor, it's your responsibility at the end of the day, as a PSM, as a process safety manager, to verify that the risk reduction factor is indeed achieved in the field and has been kept in the field over the years with maintenance and testing, so on and so forth. So it's not, although technically it is the job of your functional safety team to ensure that, but at the end of the day, on an investigation, on an audit, on the spokesperson will be the PSM person. We get to step 3. So after we leave LOPA, we go into, okay, we've received this LOPA, PSM want us to create the safety function or design the safety function. So we start recording those requirements, design requirements, operational requirements, all sorts of requirements based on hardware, software, or even operating conditions, type of service. All of those will go in a safety requirement specifications. I tend to call it your SIS Bible, your Safety Submitted Systems Bible. That's what I usually refer to it. So it has all the information how your system must have been designed and must operate and must be tested. Then we go from the design to seal, and with this seal being a seal verification, right? We are calculating using data failures, using other reliability concepts to indicate that the hardware and software that your detail design team has put together, if that achieves the risk reduction factor that you intended it to have in LOPA. You see now that the pattern is we're always going back to LOPA, right? Every phase of this functional safety life cycle is returning to LOPA for as guidance of, okay, how much risk reduction we need to achieve, and are we achieving that? So if any of these steps if you miss any of these steps, or if your functional safety team misses any of these steps, it jeopardizes that risk reduction. So now you may think that you have it, and you may have half of it, or you may not have it. You may not be working properly. We get to towards the end of that life cycle with verification, validation, testing, and maintenance, with commissioning being part of it. Operational verification, proof testing, where we will provide, when I say we, functional safety team or functional safety engineer group will provide you, will provide your operating team with proof testing procedures and proof testing intervals on how often they need to test those safety loops, the safety instrumented loops, or your safety instrumented functions. Now, keep in mind that this is in addition to the maintenance that you're doing at your plant. This is in addition to the mechanical integrity required under PSM. This is in addition to the maintenance required under PSM. This is happening parallel. These are assets that may not be recorded under your PSM records, but they exist. And again, you're responsible for going after them, finding out what those are, and making sure that you can bring those records. You can bring the responsibility under you, and or have someone that you can dedicate to be the bridge between you and that functional safety group or functional safety hardware in your plant. We've spoken about the RAGAGEP standard. Here are just some bullet points talking about it is a performance standard. So it's not like a national electrical code telling you how many plugs go in the wall and how high these plugs have to be, these outlets, but it will tell you that you have to follow certain steps. It may not tell you detailed how you go about these steps, but it tells you that you must follow these steps. You must look at all of them, even if some may not apply to your particular design or situation. And some examples here that things that we saw a few slides ago, right? This is going back to here. I'm giving some examples of those boxes, which would be your functional safety management, functional safety management plan. So if you have a safety instrumented system in your plant, you must have a functional safety management plan, which is responsibility of your functional safety management, which at the end of the day, even if you don't know anything about functional safety, you're not involved with functional safety, you are responsible for. You are the process safety management. And all of that is going to fall under you, even though you may not be aware it even exists at this point, depending on the maturity of your company. Some companies are quite mature, and I'm here preaching to the choir. Some companies are not quite mature. They may have some of these, but it's not up to par. You may not go through an audit or investigation well. And some companies, they may not even know they have it, and they don't even have an in-house functional safety person, even though they may have a really good PSM program.
Hi, Charlie, just wanted to do a quick time check. We've got about 5 minutes more before if we still want to allow time for Q&A.
Okay, thank you. So again, the 61511 being a performance criteria, you have quite a bit of leeway in terms of how to do things, and depending on the situation and on the complexity of your system, the complexity of your process, right? Some red flags that we may encounter on compliance, you will be the lack of documentation, be that one document or the entire set of documentation. And again, you can always go back and refer to it on this presentation. And the success would be a comprehensive documentation package reviewed by the auditor. Success is easy on new plants. Success is not that easy on older plants. It's not easy to keep track of all these documentation over time, especially decades. Connecting MOC to functional safety. Very early on, we said we're gonna talk about that. We're gonna use MOC as one element, as an example. The problem here would be MOC reviews often miss instrumented safeguards. The risk being that changes bypass seal verification. One example here, a colleague of mine provided me, is, does the proposed change introduce any additional demands on the SIF? If so, the LOPA should be revisited. The target should be reestablished, the seal target, and the seal verification revisited to confirm that the achieved performance still meets target. A lot of time, if the person doing the MOC is not trained, familiar with functional safety concepts in terms of how fast this functional safety, the safety function needs to respond, a mere change in set point may now require that safety function to respond quicker. And if that's not addressed, revisited, then it is not going to act on time to prevent an accident, right? So that would be the goal of this slide, is to show you that even small changes may affect your functional safety. You may say, well, but this MOC is not on my safety function. This MOC is on the BPCS, on the DCS. Yes, but now it is increasing the load or the speed requirement, the reaction time requirements of your safety system. Mechanical integrity as well. Talking about testing, proof testing is not maintenance, or is different from maintenance. Your technicians may be used to test that your typical Rosemount transmitter every 5 years at every turnaround, and those, they last forever, they are good. But why would they now want to test it yearly, as the functional safety guy is asking them to do? So those technicians, they need to be aware. They have to have awareness that functional safety has additional requirements. And even though you know that a rose mount, may last 5 years, may last until your next turnaround, but to keep that proof testing, to keep the calculation in check, or to keep that risk reduction factor at that same level, the proof testing needs to be respected. Complete integration. Here we have a summary of what we talked about on the PHA side, on the LOPA side, SRS, design, MOC, and MI proof testing. This is just bringing it out back together. Remember, the RAGAGEP compliance is required for all systems, for all items. And a PSM compliant to functionally safe and verifiable safety instrumented system. So the current state, we have PSM procedures, and we have an SIS contractor who's handling everything for us. We don't need to worry about that. And again, it's the PSM's job to not only be familiar, but do the due diligence of verifying if that SIS contractor or SIS team internally to their company is doing things correctly, are following 61511. We have some examples here. This is a topic that we're going to cover at length on our next webinar, webinar 2, functional safety assessments. I will just glance over this one here due to time, but the gap would be that your FSA, or FSAs in plural, are often unplanned, under budgeted, or deferred. And the solution would be to make sure that your project capital or OPEX budget for that FSA, not only on the cost, but on the schedule side as well. Don't make that an afterthought. And we will see implications of that on webinar 2. So this is a good hook for everyone to come back for webinar 2. We're going to be covering this, and I have some excellent examples on when it comes to FSAs and dealing with plants that don't even know about them, even though those plants have IC 61511 certified personnel and hardware. Again, this is regarding your FSA timing and how it gets costly if you don't do your FSAs when you're supposed to do. If you defer them, you skip them, that increases your cost when you have to close any gaps that are found by those FSAs. And regarding FSA, again, this is all going to be covered. This was just a little taste that I wanted to leave here with you. Competency, independency of that FSA team, people doing the audit or the assessment on your functional safety system, the independence of that group from the project, from the plant, and the competency in terms of training of those folks assessing your system. We have a cybersecurity element as well that we go over, and getting towards the end here, integrating FSA into project and operation schedules. Again, like I said, on the project phase or operations phase, CapEx, OPEX, we need to make sure that we leave space and leave money for those FSAs. All of these FSA slides will get plenty of time to go over them. Our next webinar will be fully dedicated to those. Key questions for your teams, what I alluded for in the very beginning. For each SIF, do you have a valid SRS tracing back to your PHA LOPA? Is it really going back to your LOPA? Have you validated your HAZOP LOPA, but have not verified if the SRS needs to be revalidated as well? So have you done your 5-year revalidation, found some issues, made some changes, but never thought about going to the functional safety side of things and checking that documentation to make sure that you don't need to revalidate those as well? Can you demonstrate seal was verified in design and commissioning? Do you follow documented proof test procedures and intervals for RAGAGEP, or you just bundle that all into maintenance and a lot of times move that over to or postpone that into your next turnaround, for example, right? One thing is your regular instrumentation. Another thing is your safety instrumented system equipment. Those are at a higher level of safety, and those you may not be able to hold up and postpone those into your next turnaround, which you may be able to get away with it or do it on your regular instrumentation. Does your MOC checklist explicitly address SIF impact? Do you have a checkbox there? Do you have the functional safety expert in your team? Functional safety person, one of the approvers, one of those signing off on that MOC to make sure that it would be his job to make sure that his systems are not affected. And those are in my team understands still implications of their work. That goes back to that Rosemount transmitter and why the functional safety guys are asking the maintenance team to test them more often, right? So we need a little bit of education on the technician side, just like we're doing education here on the management side, and getting you exposed to these definitions and these requirements. So as a PSM audit readiness, what inspectors are looking for: documentation package, traceability, following your LOPA finding, LOPA recommendation, all the way to what is installed. Is it being tested as often and in the proper manner? Still verification, which we've talked about, the proof testing, and MOC governance with examples of reviews referencing SIF impact. 4 quick examples here. Gap 1, LOPA done, but SRS doesn't match. That could be like a revalidation of a LOPA right after 5 years. Single integrated team, so you don't have anyone from functional safety picking up that test. Gap 2, never reviewed SIS contractor's design for SIL achievement. Well, I have a SIS contractor, and he handles everything. He's responsible for everything. Well, again, at the end of the day, as a PSM, you know more than I that you are the person responsible for it. You must do your due diligence to audit that contractor, make sure that the contractor is certified, and making sure that their calculations are up to par. Gap 3 would be an MOC never asks about SIS impact, right? In that case, updated checklist and PSM. And gap 4, proof test missed 3 years. SIS governance in my budget, which goes again to maintenance. It's not proof testing. Implementation roadmap. These are numbers that generic numbers. It all depends on how many safety functions you have, how complex your systems are. But these are 4 phases that you can go through, from doing just small checks in the beginning and getting all the way to eventually closing the loop on an assessment, closing the loop on an audit of your own functional safety system. Key takeaways: functional safety lifecycle provides validation of that claimed risk reduction. RAGAGEP requires 6.511 lifecycle discipline. We have the PHA through SIL verification and including installation, commissioning, operation as key takeaways. FSAs must be budgeted. This is a hook for webinar 2, and lifecycle documentation and traceability. That will be key for your audit confidence and reduced risk. All right, that was
thanks, Charlie. I do realize we are a bit over time already, so I'm going to do this quick poll while Charlie maybe picks 2 questions that we can answer. And if your questions don't get answered right now, Don't worry, we have them saved and we'll follow up with you separately. But in the meantime, that was an excellent presentation and a really practical look at how process safety managers can engage with functional safety requirements. Before we jump into the questions, I do have this quick poll. It'll only take a moment and it'll directly shape our third webinar in the series. And we want to make sure that the final session of these webinars is as useful as possible for you. So we're putting the topic choice in your hands. So have a look at the poll that should be up right now. Help us choose the topic and which one of these would be more valuable to you. Take a moment to vote. There's no wrong answers, just your priorities, and we'll share the results with you in just a moment. All right, feel free to keep voting. We're getting a few good answers right now. Okay, so let's take a look at what you told us. We've got not quite an even split for a third for each, but thanks, that's really helpful. We'll take these results along with the results from the next webinar and the LinkedIn poll as we finalize the topic for May 12th. So let's get to a couple questions for Charlie before we sign off. All right, let's go with this one. Unless, Charlie, you have your top two that you'd like, but if not, I'll just go down the list.
Yeah, go. You can go down the list.
All right, so let's see. Is it mandatory to have proof testing for sensor group and final elements of a SIF together to take the credits, or is it fine to do them separately at a different period of time?
Excellent question. So 61511 as a performance standard, it gives you some leeway to again, it's not prescriptive, right? So even though it says you must test that safety function, and when it comes to testing, usually we'll test from beginning to end, from sensor to final element. The standard allows you to do what it calls staggered testing, which you may test from your sensor to the logic solver, which could be a PLC or a safety relay, and you're going to test from that logic solver to your valve. Those can be done at different times, right? So, but note that they need to overlap, right? You're testing the sensor with the logic solver, making sure that the sensor will trigger the function, and that valve can be bypassed or so. You don't want to stop your service. And you will test the logic solver with the valve, making sure that when the logic solver tells the valve to close, that valve will close. So in that way, you're testing sensors and valves at different times for whatever reason, but they have to overlap.
All right, and just one more as we close this out. As far as documentation requirements per IEC 61511, which are the bare minimum, e.g. SIL assessment, SIL verification, proof test specifications, etc.?
So all of them. So we have a series of documents, and a typical safety instrumented system will require all of them. Functional safety assessments, which we'll be talking about on webinar 2, they have a series of questions. They're not audits, we call them assessments, but they will be asking for every single piece of documentation. Do you have this or not? Now, some systems may not require more than a 2-pager on one piece of documentation. Having said that, you must have that documentation, even if you say we don't have anything applicable to this, or even if you have one SIF, you're still going to have some what we call traceability, and have all the documentation necessary to design, install, commission, and maintain that SIF. So in a few words, I guess all of them, but some of them may be a 2-pager.
Okay, great. Thank you. So that Brings us to the end of today's webinar. On behalf of Accutech and Charlie, thank you so much for joining us this afternoon. I hope you're walking away with some concrete tools and a clearer framework for tackling functional safety in your PHA process. A few closing items before we sign off. The recording of today's webinar will be available in the next couple of weeks. We'll send you a link once it's posted. Feel free to revisit it, share it with your colleagues, or use it as a reference. If you need a PDH certificate for today's session, please email us at contact@accutechconsulting.com. The email's up on the screen, and we'll get that out to you. If your question didn't get answered today, don't worry, we'll follow up with you directly. And please do join us for the next 2 webinars in the series. We've got one on April 21st and another on May 12th, where we'll pick based on the poll topics. Registration links and QR codes for those 2 are on your screen now, and we hope to see you there. And thanks again, Charlie, for a fantastic presentation, and we look forward to connecting with you at our next session. Have a great afternoon, everyone.
Absolutely. Thank you, guys. Thank you, everyone. Take care.